Hello. Yes, once again we are back to our normal class. So continuation in logarithm. So we're still going to look at more questions basically on the laws and see how it operates. So in this class we'll continue from where we stopped by bringing in more examples. So logarithm. So let's look at it. Example 1. Simplify log log base 5 the square root of 625 minus log 5 in log 25 base 5. So imagine you have come across this kind of question. How do you handle it? So because first thing you must look out for is the base, if they are the same. It is only when the bases are the same that you can now begin to use the basic operation of this minus. So we know if it is minus, we eventually divide. So here the bases are the same, so that means we can apply it. We have the log 5. Now first thing, let's look at the square root. Square root of 625. Very easy. Which number will multiply itself to give us 625? We can do that. 5 can divide this. 5 here, 1, 5 here, 2, 5. So okay. 5 here, again we have 25. 5 here we have 5. 5 here we have 1. So here the square root, it means 5 times 5, one group. 5 times 5, one group. So if you are looking for the square root of number, if you use the prime number to divide the number, group them into 2 groups. So you just pick one of them. 1 here times, we pick 1 here. So and our answer will become 5 times 5 is what? And that means the whole of this is now reduced to 625. The square root is what? 25. Okay, then we can now say this is 25 divided by what? 25. So 25 divided by 25, that gives 1. And so we're going to have log 5, 1. So if the whole of this process now is log 1 to base 5. And I said if we have a logarithm, the logarithm of 1 to any base is what? Is 0. So see, therefore, log base 5 square root of 625 minus log 25 is 5 is equals to 0. So I'm trying to bring questions that will relate to each of the laws that we have established. So that's what we are typically looking at here. Okay. Now let's look at another example. If we have example 2, if we have okay, we are looking, it's okay. Okay. Show that log 3, 2 is equals to 1 over log 2, 3. Okay, change of base. This is what? Change of base. So let's try and establish it. Change of base. So see this base now. So let's look. First, we can say let this log 3 base 2 is equals to u. So we'll now establish that fact that this log log to base 2 3 is equals to log 2 raised to power u. So that this will go with this. So and if that happens, what we have here is 3 is equals to 2 raised to power u. The fact that the base is now 3, it means we are going to take log of both sides to base 3. So here, if we come here, we say log 3 base 3 is equals to log 2 raised to power u base 3. So log 3 equals what? 1. This log 3 equals 1 is equals to this. From the log will now become u log 2 base 3. So we are trying to establish that this is this. Is that clear? Okay. So now, if we divide both sides by what? Log 3, log 2 base 3, and this will be u log 2 base 3 all over log 2 base 3. So we are dividing both sides by this. So we want to, because we have already said that the whole of this log is this. So here we go with this, that u is equals to 1 all over log 2 base 3. So q we have shown that basically. So this is change of base. Change of what? Of base. So let's take a look at more example. Let's look at some example. Example 3. We see how we can apply them. Example 3. Evaluate log base 1 over 5 125 plus log base 4 base 4 log to base 4 16 minus log r base 6 1 over 36. Okay, this is what they asked us to do. But if you look at this scenario here, we will not be able to apply those laws. They can't work here. You see the bases are different. This they are different. So how do we handle this? How do we handle the situation like this? It's very straightforward. So what you usually do here, you cannot say each of these. Can say let this log 125 base 1 over 5 is equals to a. Then the other one, log 1 over 16 base 4 is equals to b. And log 1 over 36 base 6 is equals to c. So everything now is now a plus b minus c. So we now come with our normal definition here that this is for a, this is log 1 base 1 over 5 125. Here, because of here, when I say this is log 1 over 5 1 over 5 bracket raised to power a. So that this will go with this, and we'll have 125 is equals to is equals to this. So here we change it to negative indices. This becomes 5 raised to power minus 1, or bracket raised to power a. So this 125 here, it means 5 can multiply itself thrice to give this become 5 raised to power 3 is equals to 5 raised to power minus what? A. So if we equate powers, a, we call minus 3. So 3 is equals to minus 6. If we divide both sides by minus, a equals to minus 3. So similarly, we can come that b, our b is this. We say log 1 over 16 base b is, we also express it that way, 4 raised to power b. So this will go with this, we are left with this, and this 1 over 16 becomes 16 raised to power minus 1 is equals to what? 4 raised to power b. So we express this 16 and 4 as a prime factor in index form. In what? Index form. And this becomes 2 raised to power 2 multiply itself 4 times will give us 16. So this will be 2 raised to power minus 4. And here, this one will be 2 raised to power what? 2. So but there's b here, 2 raised to power. Become 2 raised to power 2b. And here, go with this, so minus 4 is equals to 2b. So your b, you divide both sides by 2, your b becomes minus 4 divided by 2, and that gives minus 2. So b is minus 2. We're saying the values. Okay, now let's squeeze c here. We come here, c, we have already known that c is this, so we can say that our c here will now become log base 6 1 over 36 is equal to log, because we're having the base at 6, log 6 raised to power what? 6. So that this 6 log 6 will go with log 6. And here 1 over 36, please take note, 1 over 36 can also be written as 36 raised to power minus 1 in negative indices. You see, this is very important in logarithm. So in order for you to do very well, please find time, go and check, read up indices. Click on my video on indices, a better explanation are there. So here, this place on the right hand side we have a c raised to power c. We express this one, this 36 as a common base in form of 6. So here we say this is 6 times 6, which is 6 raised to power 2 times minus 1, we go c raised to power minus 2, and this one is 6 raised to power c. So if you equate powers, I see that c is equal to minus 2. So you recall from initially we said that we have let everything to be this, and we have gotten a, b, and c. We put them here, a, value of a here, value of b here, and we do the what? The sums. Okay, here we have our a to be minus 3, so we say a plus b minus c. A is minus 3. Our b is, so say plus minus 2. Our c is minus, there's minus here before, then minus 2. So here minus 3, minus times plus times minus is minus 2, minus times minus is plus 2, and minus 2 plus 2 is 0. So our final answer will give us minus 3. So we cannot say therefore the whole of that logarithm, the whole of this logarithm is equal to what? Is equal to minus 3. Equals to what? Minus 3. So these are the way some questions will come. These are ways some questions will definitely come. So whichever way they come across your way, if you take your time off to look at the introductory part of this video, the proofs and all of them, you won't find it difficult. So our next class on logarithm. So we keep on bringing in more questions like that, so on and so forth. Till next time, have a nice time.